I'll be drawing dilations. Of course, to draw each dilation, you'll need a figure, the pre-image, you'll need a center of dilation, and you'll need the scale factor. Okay, so to begin with, I'm going to draw a line from the center of dilation through each vertex in my figure. Okay, now because the scale factor is 2, the new locations for these 3 points are going to be 2 times farther from the center of dilation. So I will need to measure how far each vertex currently is from the center of dilation. So I set 0 right there, and then I spin this thing, and looks like this one is, I'm going to say 1.45 centimeters from the center of dilation. So 1.45 centimeters times 2, I guess I can write this up here, 1.45 centimeters times 2 is equal to 2.9 centimeters. So I'm going to mark this at 2.9 centimeters, and that's the new location for that vertex. All right, I'm just going to spin this a little bit more, measure my new distance. This one is 3.6 centimeters, and you can use the calculator to check. 3.6 times 2 is 7.2, so I'm going to mark this at 7.2. I'm going to spin the ruler one more time in this direction, and it appears that the vertex is, I'll say 3.2 centimeters away. I'm going to double that. I'm going to mark it at 6.4 centimeters. Okay, so once we've done that, I can connect these lines. I'll use this tacky blue line, and I'm going to go from here to this point, and then complete the triangle. So as you can see, our triangle, the dimensions are twice as much. Okay, in this situation, we're going to do something very similar, except for the scale factor is only 1/2. I don't even need to go past the vertices. As you're probably already aware, 1/2 is going to lead to a reduction. So I'm actually going to measure, and this is going to seem kind of ridiculous, but I'm going to measure halfway to each vertex. All right, I think last time we said this was 1.45, and I'm going to divide that by 2. 1.45 centimeters divided by 2 should be 0.725, which obviously we're going to have to guess here, approximate. There's 0.5, 0.6, 0.7, about right there. So I think that's halfway. And then I'm going to spin. Okay, last time we said this was 3.6. Half of 3.6 is 1.8. I hope this shows up well, yeah, on that navy blue background. And I'm going to spin one more time. We said this was 3.2. Half of 3.2 is 1.6. I suppose I should thicken the line here. Half of 3.2 is 1.6. Okay, so I'm going to connect these 3 dots once again, and that's going to be the dilated image. Again, this is a reduction, and so what we see is the dimensions of our new triangle, our new image, are half that of the pre-image. Notice also that when we have a positive scale factor, the images and the pre-images are on the same side of the center of dilation. What about if the scale factor is -2? Okay, so this image is exactly like last time, and the only difference is we have a negative scale factor. So what this is going to cause to happen is, instead of doubling the distance, the negative sign is actually going to tell us to go in the opposite direction. So when I draw the line this time, I'm going to start at the vertex and go through the center of dilation. Okay, and I need to get pretty far away for each of these because it's going to be twice as far as the original vertex. Okay, so let me extend that out, and then finally, this guy, I have no idea how far I'm going to go. All right, let's get it. Fortunately, we know all these measurements already. I'm going to set 0 up right here. Okay, our first one was, I'm just going to call it 1.5 this time. Now, since the scale factor is -2, we're going to multiply that times 1.5 and we get -3. So I'm going to swing this thing around and I'm going to mark it at 3 in this direction. So don't think about the negative as, it's still 3 after the scale factor. Negative just means go in the opposite direction. All right, so let's measure this guy, 3.2, times negative 2 is negative 6.4. If it was positive 2, we would do it right here, but instead we're going to spin this around and we're going 6.4 centimeters away. Okay, I'm going to mark it at 6.4. And then finally, this guy right here is 3.6. I'm going to double that, or multiply it times negative 2, and I get negative 7.2. Okay, negative 7.2 is way up here. Mark it, and now it's time to connect the dots. Alright, so green to green. Alright, and so what we see in this case with a negative scale factor is it's twice, the dimensions are twice as great. However, it's on the opposite side of the center of dilation, and it is it appears that the orientation is different, or rather it appears to have been rotated 180 degrees. All right, and finally, just like last time, I'm going to need to go in the opposite direction. But this time I'm going to go in the opposite direction. I'm only going to go half as far from the center of dilation as the original vertex is. All right, and we've pretty much memorized these distances, but we will check it nevertheless. Okay, this is about 1.5. We're going to go half that distance in the opposite direction. Half of 1.5 is 0.75. 0.5, 0.6, 0.7, it's about 0.75 right there. Okay, this one is 3.2. I'm going to go half that distance, but in the opposite direction. So that's going to be 1.6. Swinging around. Mark it at 1.6. And then finally, this is 3.6. I want to go half that distance in the opposite direction. Half of 3.6 is 1.8, which is right there. And then I'm going to connect my dots. I do not recommend using thick blue lines to connect your dots with ugly squares on the end, but that's what I had available. Okay, and again, just as with the previous one, we end up on the opposite side of the center of dilation. And just like the one with the scale factor of 1/2, it's half the size.